Um, we're going to start with this really simple problem. I'm going to show you the 3 main ways that I see students work problems like this, as this serves as a quick review of simplifying radicals. Also, if you find that at the end of the lesson, if you're like, boy, I just don't remember radicals, we'll also be working with fractions. If you're like, I just don't remember the fractions, you can always come in for tutoring for extra practice, or you can go to Khan Academy and just search simplifying radicals. And then you should be able to, there's this thing called the internet. It has like all the information you could possibly want. There's tons of practice problems you could find. But again, if you don't work well like that, you can just come into tutoring and we can do practice problems together. So it's up to you to figure out the thing you want to do best. If you don't remember well, how to do it. Because sometimes we just have gaps, like things we just never learned well. Like for me, it's decimals. I never learned decimals very well. And I'm super nervous about it. So when I have to do it in front of people, my mind blanks and I mess up. And you think I'd never done a single day of math in my whole life. So if that's how you feel about radicals, tutoring or Khan Academy are your friends. Real quickly, you have a quiz coming up Monday or Tuesday, and I'll talk about that again in a bit. So simplifying square root of 72. When I'm working this problem, like ninja style, I just look for a perfect square that's a factor of 72. So I would look at it and think, okay, this is 2 times 36. 36 is a perfect square. Square root of that is 6. And my answer is 6 square roots of 2. And then I'm done and I go on with my life. Sometimes, though, people don't recognize the perfect squares that easily. So then we just do factor trees for the number. And a factor tree would look like this. 2 goes into 72 36 times. 36 is 6 times 6. The 6's are 2 and 3, each of those. And then what I recommend you do after you do this step, you factored it, is put everything under the radical. You're looking at these things. The 2 and then the 2, 3, 2, 3, that's part of the 36. You're looking for pairs of numbers. Most students will start circling pairs right here. Like they'll see the 3's and they'll write a 3 down. They'll see a pair of 2's and they'll write a 2 down. And what you have to do with those two things is multiply them. And then this 2 that's left over stays under the radical because there's no pair for it. So it doesn't simplify, meaning it doesn't come outside the radical. And this still gives you 6 square roots of 2. That's for a factor tree. And then I see a lot of students who do what looks like kind of like a birthday cake, like with layers. They'll do this. They'll have 72, and they'll put the 2 here, and it goes in 36 times. They might say, oh, okay, 2 goes into 36 18 times. That's 2 times 9. 9 is 3 times 3. And then they start looking for pairs, just like in the factor tree method. There's a pair of 2's that's going to come outside the radical. A pair of 3's comes outside, and then that 2 stays inside. And these are the 3 main ways that I see students do their simplifying their radicals. Okay. So chances are good one of those is your ways, and I just refreshed you on it, and we are ready to do some math. Any questions about this before we go on? Okay, thank you. All right, so that was your quick review of simplifying radicals. We are doing so much math today, it's crazy. But first, some announcements. I forgot to not accept late work after Friday, so I spent yesterday catching up on all of the late work that had been submitted. It's not in Skyward yet, it's just on my paper grade book, and I spent like 6 hours going through so many emails, so much clicking. and then realized at the end of the day I could have just deleted everything that was submitted after Friday at 11:59. So for those of you who did get their late work counted that was submitted after Friday, Merry Christmas. For those of you who worked really hard to get your stuff in by 11:59 on Friday, and then the late people got their stuff counted anyway, I'm sorry. I know that seems unfair, and I apologize. I totally just spaced on that one. My second announcement is piggybacks on that one. I'm over homework. I don't ever actually take homework grades for a lot of reasons. I have like philosophical arguments for why I don't take homework grades that I won't bore you with at this time. But the reason why I was trying it again this year is because my brain couldn't wrap, like, I usually just take daily grade checks while you're in class, and that's how I get my grades in. But we have all these asynchronous kids working, and so I was like, how is it fair that I take a grade from kids that are in Zoom, and then asynchronous kids have till 11:59? And so I was just assigning homework to try and be like fair everywhere. But I just, at the end of the day, turning in late homework defeats the point of the homework. The homework is meant to give you practice while you're getting ready for quizzes and tests. And so I really don't think late homework is a good use of my time or your time. Also, I said I wasn't going to go into the philosophy, but I'll make it fast. You may not have to do the homework to make your grades that you want. So then what is the point of penalizing you for doing something you don't want to do? Anyway, I have like 10 other reasons. I won't go into them. Here's the point. I'm not taking homework grades anymore. We're going to do what I'm used to doing, which is a little grade here or there once or twice a week that's not announced. It'll just be like a Google quiz or something. It'll just be, you'll just do it while you're in class. That way you never have to worry about late homework or whatever. But you still have a homework for every lesson so that you can have practice. It is up to you to decide how much practice you need. The quizzes and tests come straight from the homework problems, not like the exact numbers, but with the exception of the quiz that we gave you 15 points, that was just a fail of writing the quiz. But aside from that one, generally your quizzes and tests, the form of the problems is just like your homework. So do your homework if you want to make good grades, and come into tutoring if you need help. Speaking of tutoring, the third announcement, I've updated my tutoring to, it's just every morning from 9:15 to 9:45, except for Wednesdays, and every afternoon from 3:45 to 4:15, except for Fridays. If you look at your tutoring schedule, the other team teachers their names are on there for a couple days. You're welcome to go to those teachers, most especially if, like, for example, you had Miss Arnold for Algebra 2, and you understand how she teaches and her personality is a better fit for you than mine. You are free to go to her assigned tutoring day. But if you never had Miss Arnold and you'd rather come to me on her assigned day, you're welcome to. I just opened up all my afternoons. The fourth announcement, please don't submit your assignment or mark it as done if you didn't actually do anything. Like if you didn't actually do the quiz or the test, or you didn't actually submit a picture of work. It's like a huge fake for me to go open up all these emails and there's nothing attached. I don't know exactly why that's happening. Maybe you kind of want your Google Classroom to look like everything's done in case your parents look at it. But I mean, it's all going to catch up to you at Skyward anyway. So I don't know. Maybe it got you a free weekend without getting in trouble, which that's cool. I don't really know why I keep getting all these things where no one did it, but they submitted it. If there's a retake in the assignments or the classwork tab and you don't need it because you didn't fail, just pass it on by, okay? You just ignore the retake links. If you don't need it, you don't have to submit it with nothing. Just let it go. And then the last announcement, if you are present, whether it was during Zoom, like a lot of people stay for all of Zoom, a lot of people check in, they wait to know that I've marked them, and then they whoosh right out of Zoom, never to be heard from again. I couldn't even recognize them if I saw them in HEB, these children. But technically they're here every day, right? Or you do your asynchronous attendance by 11:59. If you have somehow gotten credit for attendance on the day of class, you are responsible for the quiz or test or any daily work we do during class. Like if it's a classwork that's due during class, you are responsible for that. Now, if it's homework that's due 2 days later, take your 2 days. But if it's something I picked up from you or the other students during Zoom, or that's due by 11:59 and you didn't do it, but you got attendance, that's a 0. And if it's a quiz or if it's a daily grade, you can turn it in late for 20% off. If it's a quiz or test, your first attempt grade is 0, and you are free to take the retest link, but only for up to 70. Okay, so please be aware of those things. Any questions about attendance or anything you want to put in the chat? I'll answer it for you. Excellent, because I talked too much already. Par for the course. All right, let's begin. So today what we are talking about is radicals and complex numbers. Again, your first quiz for this unit is not till next Monday. This is a shorter unit. If you don't have to right now, but if you go into your classwork tab, there's a unit 2 started with a calendar with the new printables. In fact, I have all the printables linked for the entire unit. This is a 3-week unit. You have a quiz next Monday, and you have a test the following Friday. That'll be a nice weekend because then you won't have anything to worry about. So today, hold on, I just got a thing I have to take care of. Just a second. I'm sorry. So for radicals and complex numbers, here's what we're working towards today. And you don't have to write this down. I kind of like for you to just put your pencils down and just kind of listen so you get an idea of what our goal is for class. And you don't even have to write this down. I'm just chatting math for a bit. The second half of our lesson is we're talking about something called complex numbers. Now, last unit, we talked about real numbers. We had natural numbers, and then we had whole numbers. And again, you're not writing this down. You're just chilling out, and you're just listening. Then we had integers, and we had, listen to the soothing sounds of your math teacher. I don't know about soothing. Then we had rationals. We had irrationals. And then we said when you combine those two, you get real numbers, right? Okay, that's where we ended with our number sets last unit. Now, just like when we said that if something is not rational, then it's irrational. Remember, they were horizontal with each other to show they weren't subsets. They were like just different. Well, if something's not a real number, it's an imaginary number. And honestly, y'all, I cannot remember if it's an I or not. That looks like a symbol too. We're just going to write the word imaginary. How I don't remember the symbol is like a huge fail for on this Monday afternoon. All the real numbers and we're talking about imaginary numbers today. It's anything with an I on it, which I'll explain. So if you take all the reals and all the imaginary numbers together, you have this even bigger set of numbers called the complex numbers. And complex numbers have a real part to them, which we call A, and an imaginary part, which we call BI. And this is something this is what we're talking about in the second half of the lesson. But here's the thing. Here's what I is. I is what we get when we take the square root of -1. Because in the real numbers, there is no square root of a number that's negative, right? Like if you take the square root of 4, it's 2. And the reason why it's 2 is because 2 squared would give you 4. But there is no number in the real numbers that would give you -4 when it's squared. 2 squared wouldn't give you -4, it gives you positive. -2 times itself also gives you a positive number. So that's why we had to come up with imaginary numbers. We just have to make it up. And the square root of -4 is 2 for the 4, and I for the negative 1. And that's why we have to review radicals on the first part of this lesson, because in order to talk about imaginary numbers, we have to be able to talk about square roots. And so now you can pick up your pencil, because now here's really where the lesson begins. All these words here I'm going to be talking about while I teach you, so I'm not going to read it out to you, or because that would be pretty painful. But you're not going to, just because I'm not reading it to you, you're going to get all that in the lesson as I'm talking. This first set of practice problems, you'll notice everything has a square root, and we practice square root in the warm-up, so we remember how to do that mostly. And real quickly, let me reiterate something I just told you. This. Anytime you're coming up on a problem that has square root of negative 1 in it, you're going to simplify that to this I. It's called the imaginary number. So if you have the square root of 4, the root goes away and you're just left with 2. If you have the square root of negative 1, the root goes away and you're left with I. So for example, on problem A, I'm going to break that negative 81 into two things. Negative 1 times 81. That's fair, right? That's the same thing. But now there's two things going on. There is the square root of the 81. Show me with your fingers what's the square root of 81. It's a perfect square. I'm looking at all of you on my second screen. 9, thank you. The square root of 81 is 9. Show me with your finger what's the square root of negative 1. You can't do that. That's not a thing. Why can't you do that? Because it's an imaginary number. What is the square root of negative 1? Please put it in the chat. If you take nothing away from class today, this better be the one thing. Oh, very good. Oh, very good. You're making me happy. Yes, it's I. That's why you can't show me with your finger. So the square root of negative 1 is I. And when you pull two things, or more things, out of the radical, the operation between them is multiply. So 9I is 9, well, it's 9. I'm sorry, I said that terribly. I times 9 is 9I. Right? So then we get to B. There's no negatives in B. There's not going to be an I. This is just practicing simplifying a plain or radical. Okay? Square root of 98. If you go to start your, now this is not a perfect square, so you're either doing a factor tree or your birthday cake method, or whatever your preferred method is. I'm a factor tree girl, so I'm going to do that. 2 times 49. I'm going to stop at 49 because I already know it's a perfect square. You're welcome to keep factoring to 7 and 7 if you like, and then just look for pairs. So you're going to pull out 1 7. So but I'm not going to do that because I know the square root of 49 is 7 already. So 7 square roots of 2. So we're leveling you up here, okay, on C. C has a few things going on. It has a 3 outside, and it has a negative inside. 144, y'all, is a perfect square. Please put in the chat for me, what's the square root of 144? Perfect. Do you have to remember that it's 12? Absolutely not. You could do a factor tree. You could do a factor tree all day on this. Find your pairs, pull them out, multiply. As long as you get the right answer, who cares if you're doing it fast or a longer method? It's no thing. But just for time, I'm going to do it the fast way, okay? So we really have these two things inside the radical. Square root of negative 1, square root of 144. So I simplify square root of negative 1 by making it I. And I simplify square root of 144 by making it 12. So now I have an I outside, 12 outside, and that 3 from the front. We're going to multiply all those suckers together. So 3 times I times 12, we do the 3 times the 12, and we get 36I. Did you notice there's no more negative? Okay, there was a negative in the problem, but because it was under the radical, it gets pulled out as I, okay? You try D, and then put your answer in the chat for me. And again, when you get, it's going to have a radical in it. You can just write rad, R-A-D, when you get to that part of your answer. There's a lot going on there, by the way, in D, but I'm confident you can hit it. But I'm not going to narrate it. So you look if you're done or think you have a mistake. If you're still working, just don't look until you're ready. All right, so look at my work. And what I would like for you to do is this. If you missed it, but now you're good, you looked at my work, you found your mistake, please type good in the chat. If you can't find your mistake, please type bad, and I'll get around with you later. I'll make a mark and come try to catch up with you before the end of class. Okay, I see lots of goods. Thank you. Any questions about this problem before we go on? Excellent. All right, so we have some new flavors here. Okay, there's 2 of fractions. The thing about A and B is the same thing for both of those. You'll notice that they both have negatives under the radical, which is fine. We can handle that. We already learned it. We know it's going to have an I on the outside because of the negative on the inside. But the thing about the numbers inside is when you go to do your factor tree for either one of them, it's going to be stuck because these are prime numbers, which means they do not factor further. So the only work you can do here is to simplify the square root of the negative. So really what we have going on is this inside A and this inside B. 17 cannot simplify, but the -1 can. The square root of -1 is I. So the I comes out and the 17 stays in. And the same thing is true on the B problem. 53 cannot be factored anymore, so it stays inside the radical. But the square root of -1 can be simplified. It is I. Not you. Okay, it's okay. I square root of 53. And then we get to the fractions. And there is one general principle that I'm going to tell you in a moment about when you have a radical with a fraction underneath. But the first thing I want to tell you is when that happens, make your life easy and try to simplify the fraction first. So if I'm going to scroll down so I can get this watermark out of my way. Let me rewrite this down here. So it's square root of negative 40 over 36. So when you have radical with a fraction, simplify your fraction first. So if I'm looking at 45 and 36, 3 goes into both of those, but 9 also goes into both of them. So we're going to go with the 9. So dividing 9 out of both of them gives me the square root of negative 5 over 4. So I simplified my fraction. The second thing that you want to do is make, or not, let's not say make, let's say split. Or let's say separate. I'm like, she's way too excited over the words. Separate into 2 radicals. Here's what I mean by that. 1 for the numerator and 1 for the denominator. So square root of negative 5 on top and square root of 4 on the bottom. And then you just simplify those 2 baby radicals. So in the numerator, you have square root of negative 5. This one, because 5 is prime, so in the numerator, it's just like problems A and B up here. The I comes out, but the 5 stays in. So that is I rad 5. And then you simplify the bottom. Square root of 4 is I squared to 5 over 2. Raise your hand if you're still with me. You're not feeling very comfortable, but you're sticking it in there and you're feeling like you're kind of be okay. All right. Okay. Good, because just wait till we look at this next problem. So negative 49 over 75 is a bit of a beast of a problem, only because it covers so much review material about fractions and about radicals and now about I. But I got you. We're going to survive this. And then we'll take a break and do more. It's going to be okay. It's going to be okay. All right, D. Negative 49 over 75. So I told you in the last problem to try to simplify the fraction first if you can. But in this problem, you cannot. They don't have anything. Oh, wait. I was looking at, I was like, they totally have a 5. And then I realized I wrote it wrong. 49. All right, so we can't do that. So we just go straight to the part where you break it up into a numerator radical and a denominator radical. So you write yours down. I'm going to write mine down. Okay, square root of negative 49 over the square root of 75. Now on the top, it's pretty easy. 49 is a perfect square. And we can't forget about the negative. So always remember there's really 2 things happening when there's a negative. It's negative 1 times the 49. So both of those things simplify and the radical goes away in both things. For example, when I take square root of 49, it's just 7. And square root of negative 1 is I. And And then we multiply those together, and it gives me 7i, which is grand. And on the bottom, we have square root of 75. I'm going to factor that into 3 and 25 because I know 25 is a perfect square, so I can stop right there. You are free to factor all the way to give yourself 3 times 5 times 5. Either way, you're going to get the same answer. So square root of 25 is 5. 3 is not a perfect square. It stays inside the radical. So I have 7i over 5 radical 3. It really feels like we're done, but we're not done. So you know how when we have fractions, just a regular fraction, we tell you you have to simplify or you're not finished? Well, there's a similar thing for radicals, which says if you have a radical in the denominator, you have to rationalize it. We don't want irrational numbers like square root of 3 in a denominator because if you remember your definition for irrational numbers, they never repeat and they never end. That makes it really, really hard to divide by them, which means it makes it really, really hard if they're in the bottom. It's easier if they're in the top. So that's what we're going to do right here. The way you get rid of a denominator radical is you multiply it by itself. So you multiply square root of 3 by square root of 3, and the radical cancels out. But whatever you do to the bottom of the fraction, you have to also do to the top because it preserves the value of the number, meaning this. That square root of 3 over the square root of 3, anything divided by itself is just 1. So even though it doesn't look like 1, that's what I'm really multiplying by. That means I'm not changing the value, I'm just changing the form of the number. And so here's what I would get next. By the way, this process is called, if you feel like this is another thing that you would like to go to the internets for today, or sometime soon, or into tutoring, this process is called, this is what you would Google, rationalizing the denominator, which is different from rationalizing your behavior. That's psychology. That's not math. So rationalizing the denominator is what this process is called. So when you multiply now, so we got two fractions. We're multiplying across the top, across the bottom. Across the top, you're just smushing things together. 7i radical. On the bottom, you have 5 times 3 because the square root of 3 times the square root of 3 is really the square root of 9, which is 3. You multiply those things inside. But you might have forgotten that, and you're probably just used to thinking the radicals cancel each other out, and they just leave you 3, which is true, but that's why. And then I have, for my final answer, 7i rad over 15. Raise your hand if you need this screen up still for a second. Anybody? Okay. All right, so complex numbers. I talked about this at the beginning of the lesson, a plus bi. So a complex number is all the real numbers plus all the imaginary numbers combined in one huge mammoth set of numbers called complex. And they are written in the general form a plus bi. So the real part is the a piece, and the imaginary part is the bi piece. And we say that a plus bi is the standard form for it. And I'm going to be talking about that as we work through these examples. And these are just the standard steps for it, which I will be talking about while we work through problems. one thing I want to point out, it says on step 3, if your complex number does not have a real or imaginary part, use 0 as a placeholder. And my slides are out of order. So we are going to, if you printed out your notes, we usually go from left to right on the bottom, but they're out of order, so we're starting at the right instead. So on the bottom, we're going right to left today. What we have here is 4 numbers, 4 complex numbers, okay? We are going to write them in this standardized form, a plus bi. And then we're going to identify the a piece and the b piece. Now, if you look at the a example, it's just a -2, okay? And you might be like, she just said we're going to write a plus bi. I don't know how that's going to happen. So let me tell you. -2, we talked about in the last unit, okay? It's a whole number, it's an integer, it's a rational, it is a real number. Real numbers go in the a part of standard form. Imaginary numbers go in the bi part. So -2 is the a part of this complex number. So I'm trying to write this as a plus bi. The -2 goes where the a is. There is no imaginary part to -2. How do I know that? Because there's no I anywhere. How many I's does this number have? 0 I's. Has no I's. We're literally going to write that down like this. -2 plus 0 I's. That is the complex form of this real number. The 0 is acting as a placeholder for the b. And then the next part of the instruction said to identify the a and b. The a is -2, and the b is 0. Please notice I did not include the I on the b value. It's just the coefficient for I. It's just the part telling you how many I's you have. In the math problem, not in your head, because then that answer would always be 2 for most of us. Now look at the B example. Thumbs up if that has an I, thumbs down if it does not. Does that have an I in it? Absolutely. That is an imaginary number. How many real parts does that number have? Show me with your fingers. How many real parts does it have? Perfect. None, right? None. So you probably see where I'm going with this. This is the opposite of the other one. So if this is the general form, a plus bi, and this has the I already in it, that means the b part is -4, and the a is 0. There is no real part to that number. So 0 is a placeholder. And so then to identify what a and b are, a is 0 and b is -4. And just when you're feeling comfortable, we're going to make a fraction with a radical in it and talk about how to do that. So for this part, we want to simplify the radical if we can, and we can. We already did radical negative 75 in a different example, but I'll go over it kind of quickly. So it's negative 1 times 25 times 3. So the negative 1 comes out as an I, and the 25 comes out as 5. So it's 5I radical 3 over 15. Good gosh. And the 5 and the 15 are both outside the radical, so they go together. They match up. And 5 over 15 can simplify to 1/3, right? We divide what they have in common, divide that out there, divide that out of there. So it's 1/3. So it's 1I square root of 3 over 3. There's my 1/3, or you can write it, I write it like this. There's other ways to write it. You could write square root of 3 over 3 and then I on the right hand side. The only reason I write the I in front of the radicals instead of on the right is so that it's always clear it's not inside the radical. But different teachers that you had in the past might have required different things, and whatever you're used to is fine with me. Oh, I forgot to do the A and B part. Oh, I forgot to write it as A plus BI. Okay. So the A plus BI part is there's no A, there's no real part. So when you go to identify A and B, the A is 0. And the B does not include I. The B is, what are you multiplying the I by, which is just the square root of 3 over 3. And you may have noticed, has anyone taken physics? Raise your hand. Anyone? Did you see like a relationship here between this and how vectors are written? Okay, so the -2 plus radical -48. You start by simplifying the radical, -48. This, I'm going to sort of just do this above it. It's -1 times 3 times 16. 16 is a perfect square. Square root of 16 is 4. Square root of -1 is I. So then here's what the next step looks like. This is just me just simplifying the radical. -2 plus 4I radical 3. And actually, that's already in A plus BI form. I don't even have to do anything else. There's an A part, and there's a B part. The A part is the -2. Right, so here's A plus BI. So the A lines up with the -2, so A is -2. And B is whatever you're multiplying the I by, which is 4 on the outside and 3 inside the radical. Any questions about those? All right. So we have 2 problems left to do. I'm going to do one for you, and then I'm going to give you the last few minutes to do the second one and ask me any questions about it, okay? So here we go. So just pause and look at these problems and take them in for a moment. Just absorb them. Okay. There's going to be I's. There's going to be fractions. There's going to be simplifying. But here's the first thing that I need you to do on these problems. And if you're writing, I want you to just stop and just look at what I'm about to tell you, and then I'll give you time to write it. Okay, so you're just looking. See your eyeballs, unless you happen to be sleeping. This is the very first step when the problems look like this. You have to separate it into two fractions by distributing the denominator to the terms on top. So what that looks like in the first one is 4 over 2. And then plus, okay, completely broken apart and separate from this next fraction, which is the other term over 2. Okay, you must do that on the first step when you see these kind of problems. Now you can pick your pencil back up. So first step, separate into two fractions. It's like distributive property, but with the division, with the denominator. And then now you do any math that you can keep doing. For example, 4 over 2 is 2. That's great. The square root of negative 20, I'm going to just come do that on the side over here, is negative 1 times 4 times 5, which is 2i radical 5. Which is grand and okay. But what was outside that negative 20 radical? Do you see something outside there? We cannot forget about this 3. So I have to do the 2i that's on the outside times that 3. So this is really 6i radical 5 over 2. And I'm not even done. There's like one more thing I can do. Raise your hand if you see it. There's one more thing I can simplify. You see it? Right. Hopefully what you see is this. 6 over 2 is 3. So this is a complex number. It's already in a plus bi form, so I don't have to rewrite it. The a is 2, and the b is whatever you're multiplying I by, which is 3 radical 5. And I want you to take a minute to do that last problem. Not a minute, we have 3 minutes. Take 3 minutes to do that last problem. But in the case you're ready to see work, you can look at what I'm doing. If you're not ready, don't look. Okay, so what I'd like for you to do after you look at my work is put good if you got it right. No, put great if you got it right. Put good if you didn't, but you found your mistake. And put bad if you need to stay for a minute while everyone else leaves so we can talk about it. Great if you got it all right. Good if you didn't, but now you found your mistake. Bad if you need to stay for a minute. If you're great and you have no questions, the homework is in your Google Classroom. Remember, it's not for a grade, it's just for your practice. We'll probably have a daily grade on this stuff Wednesday in class. Do the homework if you need it. Don't if you don't. That's on you. Come to tutoring. Stay if you have questions. Have a wonderful Monday. You too. Thank you.